Okay, just real quick, you don't have this in your notes, but here you're combining these two equations to form a new equation where you find the area of the oil spill as in terms of time. It's easy, really. The radius is tripling every minute. You plug 3t in place of r here, you get 3t squared, which is 9, 3t to the power 2 becomes 9t squared. I'll write like this, 9 pi t squared. That's our composite function, which now a's, the area is in terms of t. And you should realize this from your geometry, that if the radius is tripling, the area is tripling twice, or it's 9 times as big. Okay? All right. Another thing I want to do is problems like this. They're just, well, they're fun. At least I think they're fun. We'll see what you think. So, all right. We're doing f of g of 1. So we have to do g of 1 first. So you come over here, x value of 1 gives what g value? So now we need to do f of 0. So that output from g becomes an input for f, right? And what's the answer? 5. So there's the answer to that one. Fine. Try the next one. To do f, you don't have this, just watch. F of g of 2, you start with g of 2, which is negative 3, and then that goes into f. So what is f of negative 3? We're done. And once again, the output from the inner function becomes the input for the outer function. Figure out the next one. What is f of 2? And then g of 1. So go into f, and then take that and go into g. Yeah. Next one, f of 3 is negative 1. Final answer is, again. Now, here, we start with 1. What is g of 1? 0. And then it goes back into g as an x value, and this is abnormal, by the way. The final answer is 1, but it's not like it's always going to work out that the input matches the output. In fact, the next one you'll see is different. F of 3 is negative 1, but then f of 1 is f of negative 1 is not 3. It's like I said, it's not like it's always going to match like it did. In fact, watch. I'm going to do one more thing. I'm going to change this to a 3. What's g of 3? I can hear you. Thank you. My ears are old. Can't remember that. And then we're stuck. Listen, f is composed of the 7 points you see. Negative 3, 11, negative 2, 9, so forth. That's f. G is the other 7 points. Negative 3, negative 8, negative 2, negative 3. That's it. There's nothing more. So I'm saying g of negative 8 does not exist. It's undefined for that. That means this does not exist. You just can't do it. All right? Let's do it on the graph now. So which of those is labeled as f? The curvy one or the straight one? You can see right here. So f is absolute value function. This g is whatever that is. So to do this, we have to figure out f of 1 first. What is f of 1? Right here, yeah, negative 1. And now you take that output from f, and now you do g of negative 1, and you get, so f of 1 is negative 1, and g of that is 3. Try the next one. What is f of 5? It's right here, yes. And then now we do g of 1. Let me trace it this time. So we do g of 0 to start with, which is 5. And then the output from g becomes an input for f. And the answer is, so g of 0 is 5, and then f of 5 is 1. Figure out the next one. What did you get? Final answer? Let's see. G of 2 is 2. And then f of 2 is negative 2. It's kind of a funny one there. And then the last one, figure that one out. What's the answer? Yeah, because g of 6 is actually 5, and then g of 5 is 4. Okay. All right. We'll move on. Those are just like I said, it's kind of fun. Now, what we're doing now is trying to find the domain of a composite function. Let me try to explain this picture, then I'll go back and show you the two-step process we do. So, all right, first of all of this is the domain of G, and all of this is the range of G. So this is what G can accept, this is what G can produce. The green is the domain and range of F. Well, it can happen, of course, that what G can produce doesn't match exactly what F can accept. Okay? And so, let's think about it. First of all, a number out here is the number that you can't even plug into G. So definitely it's not part of the domain of the whole thing. Our goal is to find the domain of the composite function, which really is just this right here. That's the domain of the composite function. So it's not the whole domain of the first function. You start with that. You start with the domain of the whole function. But then you have to get rid of numbers like this. This is a number that you can plug into G. It gives you an answer, but the answer you get is not something that F can accept. So all this must be, like I said, you start with the domain of the inner, and then get rid of everything that can't go into F, can't go into the outer function. And what remains is your domain of the whole thing. It's kind of hard to see that, I think, with that picture, but especially we can do. We'll do some examples, obviously. You have this on your paper, and I'm not going to change it, but I guess my point is the first two steps, where it says start with all round numbers, then remove any numbers that cause a problem for the inner function, that is how you find the domain of the inner function. So you might need to just label it like this. So right, step one, find the domain of the inner function. Okay? And then the second step is where I'm going to phrase it a couple ways. Like it says here, you want to figure out when the inner function would cause a problem for the outer function. And you exclude those from your domain as well. Or put another way, and maybe I should think of a more mathematical way to say this. If you get rid of the numbers that cause a problem for the outer function, that means you're keeping the numbers that, I said keep the outer function happy, but they make the inner function produce numbers that are part of the domain of the outer function. I'm trying to phrase it in something other than terms like that. So here, let's do this. Oh, one more thing I was going to show you. Well, we'll just do examples. All right, let's do this one. And we did an example like this yesterday. It's really easy. First of all, which is the inner function? Caleb? F or G, which is inner? Yeah, because we're doing F of G. So G is going to go in place of X in F, so it becomes a new denominator, right? We're done. There's the composite function. Now we need to find the domain of this thing. And listen, I'll put it this way. I'm going to show you a two-step process that works every time. You don't always need it. I'm going to show it every time so you can kind of get how it works. But frankly, like this, we've done this before. You can just look at this answer and say, well, like what I showed you before is that can't be negative because it's under radicand, and it also can't be 0 because it's in the denominator. So we said just figure that out, and that gives you the domain, which is correct. Okay? So if you can just figure it out and write it down, I'm okay with that. Some of them are easy. That being said, let's go back and show the two steps. So you start by finding the domain of the inner, which is the domain of G in this case, which is the numbers greater than or equal to 0. You can take square root of 0. So, wait, let's see, a 1. So in this case, the domain of the inner is all numbers that are not below 1. All right? And I'm going to phrase it this way. I'm going to set the inner equal to the problems for the outer. I don't know if that's the best way to phrase it. What is the domain for the outer function? Everything except for, come on, right here. You can't plug 0, right? But that doesn't mean you can't plug 0. Actually, we can't plug 0 into here, but that's not the point. We need to make sure this does not produce a 0. That's what we're trying to do right now. So write down the inner function and set it equal to that problem, 0. Like so we can't let G produce a 0. So solve this, square both sides. And I guess I'll show that. I know what happened there. And then add 1 to both sides, and you find that X can't be 1. Which you should have been able to figure out already, but there's your process. The domain already got rid of the things below 1. Now based on this, we have to get rid of 1 as well. And so you're left with just the numbers greater than 1. Okay? So that's your process. That works every time. All right. Let's try the next one. Not that, this. And actually, this one, I'll just set it up. Is this the version you have in, like, f of g? Frankly, I just talked about the domain in the previous periods, but we'll do the algebra. Put this in place of x there. So the 4x cubed plus 1 gets squared, and then plus 3. This isn't too bad. That's 16 x to the power of what? 6. Yeah. If you multiply exponents, basically. Or if you do 4x cubed times itself, that's another way to realize that's the first term. And the middle term is what? 8x cubed, because you get 4x cubed doubled, and then plus 1. And then just double everything in there, so it's 32 x to the power of 6 plus 16 x cubed plus what? 5. I mean, because that becomes 2, then plus 3 is 5. Be careful, don't put 4. Don't be sad after all that. Now, so that's our answer. That's a composite function. The domain, hopefully it's obvious, is going to be all real numbers and something like this. I mean, there's no problem. Like the inner function has a domain of all real numbers. The outer function also has a domain of all real numbers, which means there's no output g can produce that would cause a problem for the outer function, right? So actually, it should be obvious. This one. Now, this one, I want to do this, but you don't have this on your paper. Just for the record, though, if you did it the other way around, you would have to cube that binomial. Which we need to do sometime, but just not today. This one you have. Let's do this one. Which is the inner? So f is going in place of x, so f becomes the denominator in g. So there's your composite function, except we need to simplify our answer. So dividing by that fraction is the same as multiplying by the reciprocal of that fraction. And it's always a good idea, by the way, to like simplify or cancel before you multiply. But nothing cancels, does it? Which tells you that after you simplify, while you may be tempted to cancel something, there is nothing to cancel. You don't have a common factor that cancels. Okay, that's it. Now, first grade I messed up, which you often do, because this really isn't the whole story. If I look back at my original unsimplified answer, what number obviously cannot go into the function? 0 is okay. -3, right? But you lost it here, which means you must state it. So be careful. Do that every time. Look at your original setup. That is the answer, which means after you simplify, if anything kind of went away by doing the algebra, you need to write it down. That's your correct equation. So once again, if you graph this in the calculator, it would not have a hole at -3. But if you graph this in the calculator, it would. Okay? And so, anyway, all right, now let's figure out the domain. And I want to figure it out. We'll do the two-step process first, okay? Once again, you don't have to do the process, but first you find the domain of the inner, which is, there is f. So -3 is definitely out already, right? So f is everything but -3. And then we said you set the inner equal to new problems. If you want to phrase it another way, you can. I don't care. So the inner is f. So we want to figure out when this would cause a problem for g. And when would g have a problem? When you plug in 0. So I'm saying f cannot produce a 0. Well, but look, a fraction equals 0 exactly when the numerator equals 0. So you can either just set x plus 4 equal to 0, or if you want to, make it a proportion, cross multiply, and this way you get x plus 4, and this way you just get 0 anyway. And then obviously you get that x can't be -4. So x already couldn't have, the domain already couldn't have -3. Well, it also turns out it can't have -4 either. So there's your domain. Now, I want you to appreciate the fact that you could have figured all this out just by looking at this fraction. So first of all, obviously we said, if you plug -3 here, this denominator is 0. You can't have that. But listen, this whole thing is under the 2, isn't it? This whole thing is a denominator, and that whole thing cannot equal 0. And so you can't put a -4 in here because that makes this whole thing 0. So we don't care usually if a numerator is 0. But this numerator being 0 makes that whole thing be 0, and you can't have that because you get division by 0. So I'm saying you can figure this out just by looking at it in this case. Now we're going to do it the other way around. Doing f of g. So now g goes in place of x everywhere in f. So you get 2 over x plus 4 in the numerator, and then 2 over x plus 3 in the denominator. Now once again, there's 2 ways to fix this. You could multiply the 4 by x top and bottom, get a common denominator, and combine them, but I'm not going to do it that way. I'm just going to multiply the whole numerator by x and the whole denominator by x, like so. And I kind of vacillate between those two options. So this time I'm going to do it this way. If I multiply it through by x, the first one becomes just 2. 2 over x times x is just 2, plus what? 4x. Don't forget, you're multiplying the x times both parts. And so here, x times the first part is 2 again, plus 3 times x, so 3x. Can I cancel those 2's? Please say no. No. Now, one thing we need to glance back here and see, what number obviously is not part of the domain here? Right there, what you not plug in? 0, right? So what you lost here, so you need to note it. Your answer to be complete needs to note that x can't be 0. All right, now let's find the domain. This time, let's try to do it without showing, well, maybe not without showing any work, but we already noted that x can't be 0. But it's also true that this whole denominator can't be 0, right? So you might just say, well, I need 2 over x plus 3. I need that to not be 0 because it's a denominator. Move the 3 over, you get -3. And then cross multiply. There's other ways to do it, but you get -3x equals 2. You get -2/3. You can't have that because, once again, if you plug a -2/3 in here, here, watch this real quick. If I do that arithmetic, if I plug -2/3 in place of x, I get this. Dividing by 2/3 is the same as multiplying by the reciprocal, isn't it? So you end up with -3, which plus 3 would be 0, and that's the problem. All right. Just bear with me. I'm going to go back and show the two-step process, how it looks there. I'm going to give the same answer. All right. What's the inner? G. And obviously you can't plug 0 into G, so we got that. Now, you set inner equal to a problem for the outer. What's the problem for f? So you say, okay, 2 over x, cannot put a -3 there, cannot produce a -3. And you solve that and you get the -2/3. We kind of already did that algebra, okay? So like I said, either way of looking at it is fine. Two radicals. Kevin? You want to get radical? I'm sorry. That was just sad. All right, plug f in. Let's do this quickly. You plug f there, and it's just that minus 2, which you just get x squared plus 2 when you're done. And once again, you cannot simplify that because it has to look like this before you can cancel, and it doesn't. So we're done. That's the answer. Let's go through the process. The inner function is f. What's the domain of the inner function? All numbers, okay? All right, fine. Now, this is kind of funny. We set domain equal to a problem for the inner. Let's set inner, no, let's set the inner equal to problem to the outer. I thought. So this is going in here. So the domain of this is radical, so it needs to not be negative, which means x can't be below 2. So that means f is not allowed to produce anything below 2. Actually, I said it this way. We want f to not be less than 2. What's the same thing as we want it to be 2 or more, right? You can say it either way. Well, look. First of all, let me not do any algebra. Let's just talk about what has in there. What is the smallest value x squared can ever produce? 0, yes? If you plug in 0, you get 0. If you plug in -1, what do you get? 1. So, -1 or 1 gives you 1, so that becomes 5 that. Therefore, 2 gets you 8. 2 or -2 gives you 8. And so the lowest this could ever be is 0. I mean 0 plus 4 is 4. There's never going to be a problem. It'll never be true that this is less than 2, will it? So what's the domain? When do you have a problem? Never. So the domain is all real numbers still. I'm saying the answer is that the domain for this problem is simply all real numbers. If I do the algebra now, if I subtract 4 from both sides, I get that. And once again, you should just realize that x squared is never negative, right? And so it's definitely always going to be greater than -2. So therefore, it'll never fail. The domain is all real numbers. Now we do it the other way. This one, here, I'll go and set it up first. You have g going into x, right, into f there. That means we're going to need our identities. So here, you have two identities, and I've been using x when I write them. It's probably better to use something like a, because whatever you plug into it, if you have something squared, then square root, it cancels, except we said in this case, you can never get a negative result, so we express it that way. Whereas if I switch it around, so it's the square root, and then squared, here, it cancels just giving you a, but you can't have negatives because you start with the square root, and you have to write it like that. It's not all of a's, only non-negatives, okay? So this is going to seem kind of weird. What we have matches the second case, so you say, okay, those cancel, and what I write down is a, but a can't be, can't be below 0. That means x can't be below 2. Actually, you have to write that down. And the comma doesn't go there because I need to put the +4 there. So it's kind of weird. You do the algebra, but then you have to write this down off to the side. Because the answer isn't just x plus 2, which this gives. It's that part of x plus 2. That's our composite function. Now this one, we kind of already gave it away. I mean, the domain is what you see there. Let's just go through the two-step process, though. First of all, the domain of the inner, well, that's the domain of the radical, which is all the numbers greater than or equal to 2. That's the inner. And then the second process, you figure out when the inner causes a problem for the outer. Except the outer function never has a problem, right? So you just don't get anything from that. So you start with the domain of the inner, then remove anything that would, anything when the inner causes a problem with the outer, except for that just didn't apply here. So we're done. All right, one more. This is the best one. We're doing g of g. So let me lay out g. You do that, and then what goes into g? G. And you cannot simplify that. Just write it down. Now, which way do you want to do it first? With a methodical, two-step process, or just try to figure it out? Try to figure it out? All right. Now, for sure, x can't be below 2, right? If you plug in 1, you immediately get a negative. That's bad. So 2 works here. But let's go with 2. If you get 2 here, you get 0. Square root of 0 is 0. But then 0 minus 2 gets your negative under that radical. So 2 actually doesn't work. Anyone tell me the smallest number that would actually work for both radicals? Now, I heard 4. It actually has to be bigger than 4. 4, let's try that. If you try 4, you get 2 here. Square root of 2 is okay. But isn't square root of 2 less than 2? And so you get a negative, and that's bad. So 6 is the smallest. 6, you get 4. Square root of 4 is 2. 2 minus 2 is 0. That's the smallest number that works. You're done. That's the answer. If you can figure that out on a problem like this and write it down, I'm happy for you. Take that. That is the correct answer. That is the domain. You're done. But I want you to see what happens when you try the two-step process. So, what is the inner? G, because it's both. And so the domain of G, the domain of the inner, is the numbers greater than or equal to 2. Okay? And for the second part, you set G. Well, G is going into itself, so it needs to make sure it doesn't produce numbers below 2. Right? We set the inner function because that. Let's do the algebra. So we square both sides. Add 2 to both sides. And so you get this. Now listen to me though. The domain is the numbers that make both these true. So it's only the numbers that are greater than or equal to 2 and greater than or equal to 6. But isn't that the numbers that are greater than or equal to 6? I mean, 2 makes that true, but 2 doesn't make this true. 4 makes this true, but it doesn't make this true. Which is why 2 and 4 work for the inner radical, but didn't work for the whole thing. But 6, of course, works for both, and everything above 6 works for both. So I'm saying, if you try and do something like this, you want the numbers that make that inequality true, and this one, well, it's just going to be the bigger one, okay, every time. So it's kind of weird. Listen, this stuff, it's not that hard if you're clear about how the numbers are supposed to work out. You know, don't just blindly try to do some algebra, but make sure it makes sense when you're done. And it's doable, okay? That is it.